Hi and welcome to this video where I'm going to talk about how you can use moles and relate them back to chemical equations. It all comes down to one key idea, and that is what your chemical equation actually shows. Okay, so what we need to do first off is become really familiar with what a balanced equation is actually telling us. So what our equations are telling us is how many particles are present and reacting in a given reaction. Okay, and moles are just a way of counting particles, so it kind of all works together once you get there. So if we take an example, here's a reaction that you will have come across in level 1. Sulfuric acid reacting with sodium hydroxide, making sodium sulfate and water. Now the important things to see in this reaction are actually the coefficients, the numbers in front of the formulae. So sulfuric acid, you'll see, has no number in front of it, which means that we're talking about one particle of sulfuric acid. There's a 2 in front of the sodium hydroxide, there's no number in front of the sulfuric acid, and there's a 2 in front of the water. These numbers tell us the ratios in which the particles are reacting with each other. So this equation really is saying one particle of sulfuric acid reacts with 2 particles of sodium hydroxide to form 1 particle of sodium sulfate and 2 particles of water. And that is a way to really visualize what's happening in the reaction. Okay, so the chemical equation's telling us how many particles are reacting. Here it is again, just so you can see it. 1 sulfuric acid to 2 sodium hydroxides make 1 sodium sulfate and 2 waters. And that is a ratio that we can use. It is a ratio of particles that are reacting. And we count particles using moles. So if we have 1 mole of sodium hydroxide, remember if you look at that ratio, you've got twice as much sodium hydroxide as you have sulfuric acid. So if we've got 1 mole of sodium hydroxide, then we must have half a mole of sulfuric acid that reacts with it. Similarly, again, if you compare sodium hydroxide to sodium sulfate, you can see that there's 2 sodium hydroxides to 1 sodium sulfate, half as much sodium sulfate. Therefore, if we've got 1 mole of sodium hydroxide, we're going to have half that amount, half a mole of sodium sulfate. If I want to make 2 moles of sodium sulfate, again, I'm going to go back and look at the equation and look at the ratio. Sodium sulfate, sulfuric acid, you can see they both have 1s in front of them. Invisible ones, but they're 1s. So if I need 0.2 moles of sodium sulfate, then I've got to start with 0.2 moles of sulfuric acid. Now, that's moles, and that's fine, but it doesn't actually work that well unless I can go to a balance and weigh out 0.2 moles of sulfuric acid, for example. So more often than not, masses are what we want to work with because we can use mass and we can measure mass much more easily. Or volume, which I'll talk about later. We'll talk about volume and concentration in another video. Because our equations work with moles, but all our equipment works with volumes and masses, we need to be able to easily convert these, which is what I was talking about in my previous video. So for example, again, if we stick with this equation, I like this equation because it's not one-to-one. How much sulfuric acid, if we had 10 grams of sulfuric acid, how much sodium hydroxide do we need? And how much sodium sulfate is formed? Well, let's have a good look at that in just a moment. So, here's our equation, here's our question. How much sodium hydroxide do we need to react with 10 grams of sulfuric acid? Remember that little equation I gave you in the last video as well, moles equals mass divided by molar mass. We can rearrange that as need be. So, if we have 10 grams of sulfuric acid, what does that really mean? Well, It means we have 10 grams of sulfuric acid. We need to work out how many moles we've got, because the equation is all about moles. It's not about masses. So to work out the number of moles of sulfuric acid, we need to know the molar mass of sulfuric acid. So we've got to take hydrogen, which is 1.01. We've got 2 hydrogens. Sulfur, 32.07, and oxygen, 16.00, and there are 4 of those. So we add them all together, and we get the molar mass of sulfuric acid as 98.09 grams per mole. From that, we can work out the number of moles of sulfuric acid, 0.102 moles of sulfuric acid. So mass, 10, divided by molar mass, 98.09. We've got the number of moles. Now we can look at our equation. So for every mole of sulfuric acid, we need 2 times as many moles of sodium hydroxide. So the moles of sodium hydroxide is 2 times the number of moles of sulfuric acid. So we're going to have 0.204 moles of sodium hydroxide. So see that ratio? Sulfuric acid is half of sodium hydroxide. Sodium hydroxide is double sulfuric acid. And we've got that 0.102 of sulfuric acid and 0.204 of sodium hydroxide. Now that we know how many moles of sodium hydroxide we need, we can work out the mass. Mass is moles times molar mass. We need to work out the molar mass. So sodium 22.99, oxygen 16.00, and hydrogen 1.01. So that gives us an exact number of 40.00 grams per mole. We can put that back into the formula. So multiply that by 0.204. And we find out that we need 8.15 grams of sodium hydroxide. So even though we have twice as many moles of sodium hydroxide, it's still actually a smaller mass than our mass of sulfuric acid. That's because the molar masses are different. They're different sized particles, effectively. So a particle of sodium hydroxide is less than half the size of a particle of sulfuric acid. This is why masses on their own aren't particularly useful. Now, following on from that, if we have 10 grams of sulfuric acid and 8.15 grams of sodium hydroxide, how much sodium sulfate do we produce? Let's have a look at that. So, how are we going to find this? Well, first thing we need to do is start with what we've already worked out. We know that 10 grams of sulfuric acid is 0.102 moles, and it reacts with 0.204 moles of sodium hydroxide. So looking at that equation, at the top on the balanced equation, you can see that the moles of sodium sulfate and the moles of sulfuric acid are the same. It's a 1-to-1 ratio. So if we need 0.102 moles of sulfuric acid, then we're going to produce 0.102 moles of sodium sulfate. From this point, the equation actually becomes quite straightforward. We do need to know the molar mass of sodium sulfate, so 2 sodiums, 1 sulfur, 4 oxygens. We've got a molar mass of 142.05 grams. And therefore the mass of sodium sulfate that is formed is the number of moles times the molar mass, multiplied all together, and we get our answer of 14.5 grams. So you can see 10 grams of one, 8 grams of the other, and we've got 14 grams of product. The numbers in the equation don't relate to masses, they relate to moles, and that is the most important thing. It is, you can think of it as a mole ratio. Those numbers in your chemical equation at the top, think of them as a mole ratio, the ratio of moles of reactants and products. So the only way you can put masses in there is when you do these calculations converting through moles and mass. Otherwise, it is purely a mole ratio. Okay, in my next video, we will be talking a little bit about concentration and relating that through. I will see you then. Good luck.